So children, now let us discuss question number 12 from the evening session paper which was held in the month of January 2023. Okay. So coming to this question, first of all, I ask you to read this question at least 2 times so that you will understand better what is going on here. Okay. So take a pause, read this question for 2 times. Okay. Then you just look at me so that you will understand better. Okay, you can understand better if you read the question at least 2 times. I say that this is direct question if you understand the depth in that question. It was given that a body of mass is there which is tied to a spring. So here itself we have to understand spring is given. So spring, the name spring, you could observe in chapter, which chapters you could observe? Can you please tell me? In work power energy, in oscillations, there you could observe the spring or spring constant. Okay. So here spring constant is mentioned. Spring constant is mentioned. So it means, what is the spring constant? Given by the symbol K. Okay. So just recollect whatever you have studied in your junior enter. Spring constant is given by the symbol K, and it mainly, if you observe, it comes in the chapter work power energy as well as oscillations. So what is happening here is that circular path is there. So circular path means you have to think that there is a centripetal force. Okay. So angular speed is given. It means that you have to express the centripetal force in terms of angular speed. Then the ratio of extension of the spring to its natural length. Okay, everything is very clear. So what we have to do here is that due to the spring constant, what is the force? What is the force? What is the formula for the force? So F is equal to Kx. This is what the formula we know due to spring constant. Okay. So what is the value of K? So this spring constant, this one is there now, 12.5. This is nothing but K. So K is given as 12.5. Okay. What does this X stands for? X stands for extension. This extension itself is known as X. Okay. Now, since it is rotating in a circular path, you could say that the other force is centripetal force, which is mv square by r. But the problem is that the concept, if you look at the question, it was mentioned that there is an angular speed of 5 radians per second. He did not tell you it is a linear speed. Linear speed means you have to say that its symbol is v. Linear speed in the sense you have to say its symbol is v. So whenever he tells you that it is an angular speed, you have to say it is omega. So now it's time to think, how can I express this centripetal force in terms of omega? Children, you have studied that the relation between linear velocity and angular velocity as v equal to omega r. Isn't it? So from this, v by r will give you omega. V by r will give you omega. So here, omega, v is equal to omega r, no? So that one I will use it. Omega r whole square by r. So you could get it as m omega square r. So this is the formula for centripetal force. So now we are having 2 formulas. One formula because of the spring constant, okay? So the force by the spring, force exerted by spring is F equal to Kx, or you can say spring force, and other force is centripetal force. Since it is rotating in a circular path, you have to consider the centripetal force either mv square by r or m omega square r. Like this, my dear children, you are having 2 different forces. One is because of spring and another one is because of a centripetal force, because of a circular path revolution. Now what he is asking is that you have to find out its natural length. Okay, how to find out this natural length? Clear? So initial length is L, which we call it as a natural length. Okay. Extension is X. So why don't I take this circular path radius as initial length L, or you can call it as a natural length. Okay. Plus extension, which is equal to m omega square into L plus X. Now I say that this is equation 1, whereas this is equation 2. So to maintain this in equilibrium condition, okay, so I have to say that equation 1 equal to equation 2. So from this, what is equation 1? That is spring force, and from equation 2 it is centripetal force, like this, okay, since it's moving a circular path. So here the spring force is K into X, whereas this is m omega square into L plus X. Like this we have to write, my dear children. Okay. So if you want to draw me the diagram, so like this, what is there here? Initially there is a spring. So this is a symbol for the spring. So let this point be O. Let this point be O. Okay. Now it is moving with an angular speed omega, where k is nothing but spring constant, which is connected to a body of mass m. Connected to a body of mass m. So now it is taking a circular path like this. So let us substitute. What is the value of k here? K is nothing but 12.5. Okay, we don't know the value of x, that we have to find out. Which is equal to, where mass m is given as 200 grams. If mass m is 200 grams, we have to write down in kgs as a system. Okay, so how can I write that? M equal to 200 grams, where m is nothing but here mass, right? So kgs in the sense 200 by 1000 we have to write. So conversion of gram into kgs, or else you better write like this: 200 into 10 to the power of minus 3 kg, because 1 kg is nothing but 10 to the power of 3, 1000 grams. If you want 1 grams, you have to shift this to other side. That means you have to shift this 10 power 3 to other side. It will become 10 power minus 3 kg. Okay. So 1 gram can be written as 10 power minus 3 kg. Let us substitute that. So here 10 power minus 3 kg has been substituted. Okay. So mass is nothing but 200 into 10 to the power of minus 3. So this is what is mass. Into omega square. So what is omega? So already I mentioned the angular speed is 5 radians per second. So you have to write this 5 whole square into natural length is L, extension is X. So we don't know both. He is not asking L and X, he is asking the ratio of extension to length. It means he is asking the ratio of X by L is how much. This is what he is asking you. Okay, my dear children. Now let us do this. So what happens here is that 125, 12.5, I can write it as 125 by 10 into X, and this I could write it as 2 into 10 power minus 1, and this 5 square is 25 into L plus X. Like this I could write. Okay. So this one and this one I could cancel out. 25, 5 is 125, I could cancel out like this. Now what I get here is that 5x is equal to 2 times of L plus X. So this 2 we can cancel out with 2. So 2.5x is equal to L plus X. If I move x this side, I'll get 1.5x equal to L. So 1.5x equal to L in the sense nothing but you can write 1.5 as 3 by 2. X equal to L. So he's asking x by L. So whether better to shift this 3 by 2 to other side. So x by L is equal to 2 by 3. From this, x is to L can be written as 2 is to 3. So this is what is the ratio of extension to natural length. So it comes under which option, my dear children? It comes under which option? Nothing but option 3. It comes under option 3. Okay. So look once again whatever I have done carefully. So I have taken the two forces because of spring, that is F is equal to kx, and another one is because of its circular path, I have taken it as m square by r. As per situation, velocity is not given, omega is given, that is angular speed. So I converted that m square by r to m omega square r. So once I get these two forces, I know that if you want to maintain a circular path, these forces must be balanced out each other. So that is the reason I have taken the spring force is equal to centripetal force. Okay, that is kx is equal to m omega square r. So in place of r, the radius has been because of extension of the spring. You have to write its natural length plus extension. Okay. So with this I conclude that for the given question, option 3 is the correct option.